Welcome to the third session of the day. I, Mrs. Manasi Shirurkar, Assistant Professor, Maharashtra Education Society's Institute of Management and Career Courses, Pune, welcome all the participants and today's guest speaker for FDP in Artificial Intelligence for Education, hosted by IMCC in association with Atal and AICTE. A small introduction about our college. Institute of Management and Career Courses, IMCC, under the aegis of Maharashtra Education Society, is having 37 years of standing in the field of IT and management. Affiliated to Savitribai Phule Pune University, New Delhi. We have MCA, which is accredited by NBA, MBA programs. In addition, IMCC is a recognized PhD research center under the Faculty of Commerce and Management in SPPU. We do have BBA, BBA CA, BBA IB courses as well. The total student strength on campus is around 1,000. Glad to introduce an eminent speaker of this session. Professor Kamal Bijalani leads several ICT-based educational technology and pedagogy projects such as AMPLE, AView, and others. AMPLE is the LMS with advanced pedagogies like outcome-based education, personalized learning, reusable competencies, blended course creation. Professor Kamal Sir holds patents for classroom exam proctoring and assessment devices. He is the designer of the AView platform developed by Amrita for interactive online classes installed at 12,000 institutions under Ministry of Education. Using AView, lakhs of teachers and students have been trained. Earlier in USA, he was technical lead at AI startup companies from MIT and Stanford. With Kamal Bijalani sir, few more of his associates are also present. Madhuri SS ma'am, Pradesh and sir, Jayahari KR sir. Welcome to you all too. This pandemic has made a drastic and essential change in the traditional classroom teaching. Globally, the students and facilitators are hatched with each other with online class teaching mode only. So sometimes it's challenging to engage the online teaching, so making the class environment smarter as it is the need of the day. So on the same line, today's guest speaker will be addressing on smart classroom environment. He will be discussing research opportunities on AI in education, briefing about predictions, recommendations, and analytics in assessment models with its performance in examinations. In addition to this, he will be enlightening with demonstrations on personalized learning using difficulty levels, demonstration of evaluation analytics, demonstration of outcome-based education for program evaluation, question bank calibration, and some more experimental analysis. I request Kamal Bijalani sir to start with his talk. Over to you, sir. Thank you.
Thank you so much, Professor Manasi, for that wonderful introduction. I am again, on behalf of Amrita Vishwa Vidyapeetham and our e-learning research lab, we are really glad to be able to have this opportunity to come and present work in AI and assessments and evaluation with all of you. So just to give you a very brief overview, I was in US for many years, and I started my work in AI over there, and that was in the 90s. And in the 90s, the main thrust in AI was in areas like expert systems. And the main language we were using at the time was Lisp. So I was, very proficient programmer in the Lisp programming language, and later there was another programming language like Prolog, which came along. After that, the AI field From expert systems, neural networks became the major sort of hot thing, So neural networks was used to model various problems. And over time, that has led to a lot of algorithms in machine learning, basically. So a lot of approaches and algorithms in machine learning are prevalent now. And those are also, lead to a field called as deep learning now. So as an overview, in that deep learning, basically when we need to train the algorithm with data or with many examples or objects or whatever we are training the algorithm with, and then based on that training, the algorithm is able to predict or classify or recognize something. So that area of using AI is another subject. Today, we'll be focused on assessments and evaluation. So it's very important to, I would just like to say at the onset, AI is also becoming like a buzzword, and, so we should be careful. I mean, many people call anything that is automated or anything that is done is called AI. So having this perspective, we should be careful. I mean, AI is good to use. We are doing some automation of things. And whenever we do automation of anything that was previously manual, there is a tendency to call it AI. And that is fine. That is fine. I think, we should be proud that we are able to automate so many things. But at the same time, we should keep a balance and make sure that, for example, when we are talking of assessments and evaluation, whatever be the problem area, whatever be the area in which we are applying it, we need to go very deep in that area and understand the problem, understand the requirements, and then very carefully build the solution. AI is not going to be like a magic wand or a magic wand that you just wave it and the answers will come out for us. No. The traditional way of identifying the problem carefully, analyzing the problem, finding out the various trade-offs is still intact. So as an engineer, as a scientist, we still need to do all of that. And then, see what are the techniques of AI which are relevant to this problem and which can be used. So that carefulness, that awareness is very important. Otherwise, we will have very high expectations of AI and we may get disappointed. So with that brief introduction, I'd like to share my screen now. And let me do that 1 second. So I'm sharing my screen, and I'll just stop the video to make sure everybody can see. Can someone tell me if my screen is visible?
Yes, sir.
Thank you, thank you. So today's, agenda is sort of summarized here: AI in assessments and evaluation. We can use AI to classify, recommend, predict, analyze, as I was saying. Today's thing, we are dividing mainly into 3 parts. The first, we will be showing you an actual demo of a system. Our system is called Ample, by the way. And we sometimes use it with different trademarks. So today, Madhuri will be demonstrating personalized learning next. And personalized learning is, again, to do personalized learning, here we have questions. So what we do is either we can classify the question into different difficulty types. So we have, 6 difficulty types in AMPLE. And here Madhuri will be demonstrating a system which has 3 difficulty types. So hard, medium, and easy. We can also classify these questions according to Bloom's taxonomy levels. And there, we go from remember, understand, analyze, and so on. So we could also build a personalized learning model in AMPLE using Bloom's levels. If that can also be done. In regard to personalized learning, we'll briefly say how questions can be calibrated and how students at risk can be identified. Next, Pradesh will share with us our existing outcome-based education, which is needed for NBA accreditation, and how that is available in AMPLE. And then we will discuss how that can become AI in the sense that once you have a course attainment or a program attainment at the institution level, how that can be used to predict what will happen in the next semester. Then finally, one of the most important thing that we are missing from a pedagogy point of view is that whenever we are teaching in class, every once in a while we need to monitor how much all the students have understood. So we feel that is very important, very critical, and it's really missing from our day-to-day teaching right now. So Jehari will be bringing that out. How do we do formative assessments regularly, and how do we use AI to bring about when to do formative assessments? He will also share an invention that we have for doing formative assessments, for which we have a patent, and how AI is being used to build that invention. Okay, so basically coming back to personalized learning, we will start with a demonstration by Madhuri. So Madhuri, hope you are ready to share your screen, and you can give a demonstration of how a student will conduct. You can go ahead and share your screen while I'm introducing you, Madhuri. I'm going to stop sharing my screen now. So I've stopped sharing my screen. So Madhuri will tell us she's logged in as a student here. And here, this application is called Omnex Live Learn, but it is the same application, Ample. It's just renamed for the corporate world. So Omnex is a multinational US company that is also using Ample, and they are in the field of quality. So, ISO 9000, and so they do training in quality, and they are using personalized learning. So Madhuri will demonstrate how a student comes here and takes a quiz and how it runs, and I will describe it along with her. Go ahead, Madhuri.
Good afternoon, everyone. I'm Madhuri, and I'm a software developer and working for the Ample software. And also I'm doing my PhD in education technology and pedagogy. And currently I'm just showing the course which we have developed. And here we have implemented the personalized learning test, which is considered to be leading edge of assessment technology. We are designed to adjust their level of difficulty based on the response provided. If student gets wrong answer, computer gives easier question, and student answer correctly, then next question will be more difficult one. This ability, this will make us like measure the ability of student more precisely. So Here you can see, currently I'm showing the demo of Ample course system. Currently this is the student LMS view. In the left hand side, you're seeing the pre-test, and we have chapter 1, chapter 2, chapter 3, we have 3 chapters, and the final post-test is in the last node. So currently student, you can see the chapter 1, and you see APQP introduction. Suppose like if this is a video, student is watching this video, and right after watching this video, they go to this test. So this is the personalized learning test. And here we are testing 2 learning objective, which student has learned in this video. So how currently this, I'm just going to test these 2 learning objectives. Let me just get started. So as you can see, the first question is thrown to student, and the difficulty level is medium.
Madhuri, just 1 second. Can everyone hear Madhuri clearly, or should she speak closer to the mic?
That will be better. Sorry, but if the sound is a little bit increased, that will be more better.
Madhuri, can you a little closer to the mic? You were doing that for 1 minute, and then again it became less.
Okay. So me now clearly?
It's better. Yeah, thank you.
Okay. So all of you, I hope all of you are seeing this question. So currently we are in the first question, and in the beginning we are asking the medium level question to the student. And there are 2 options, and I'll select the correct answer. Just for the demo purpose, I have marked it, the false one is the correct answer. So
right, 1 minute. So on the right side, notice on the right side, we are giving you a trace of what is happening. On the right side, you see that the learning objective is A1, and the difficulty level now, has become hard. It was medium previously. She got the answer right, so it became hard. Go ahead, Madhuri.
Okay, yeah. Now I'll answer this correctly. So it will move to next learning objective. So in the learning objective 1, you have attained above level actually. So in now currently automatically this system switched to the second learning objective, and that is mentioned here, that describe the key objective of APQP. So here I'll answer it wrongly. So you can see it was medium question. Since student answered it wrongly, it is come down to easy level question. Suppose let me say I'll answer it correctly. So now you can see their attainment in these 2 learning objective. In the learning objective 1, he is competent above. He has learned everything and he understood the concept. And the learning objective 2, he is not yet competent. He has not cleared it actually. Sometimes if you have more content, we are giving the recommendation also here, the recommended content to watch to become competent.
So 1 second. So basically, what we are saying is that not only we detect, this is a very simple example. For lack of time, we're just giving a very simple example. That go ahead and show that graph, then I'll describe it. Yeah. Scroll down a bit. Yeah. Go ahead, Madhuri.
Yeah. Currently, you are seeing the graph where you can see how this student has performed. In the learning objective 1, he is competent above, and the learning objective 2 is not yet competent. So this will give student where he is in, and in this which learning objective he is weak, and which he has to focus more. So he can go and watch again, and he can take the test again. Like unlike other normal tests, here the questions are not set by any teacher. It's machine automatically picks the question and gives it to throw it to student. So based on their understanding, each student will get different set of questions.
Right. So this is a student login, and as we are saying, this way the questions are given automatically by the system. So from if you are the teacher, what do you have to do? You have to make sure that there are enough questions. And then you can configure the number of questions also. Later, we can show you that also. So I just like to pause here for a make sure that you have understood this concept. Let me summarize it. Student took a test. The question difficulty level is pre-configured by the teacher. So teacher creates some questions at easy, medium, and difficulty levels. And then the questions given to the student during the quiz for each learning objective go up or down depending upon the performance of the student. I hope this is clear. If anybody has a short question, we can take up one or two questions at this point.
Sir, we have question session after completing the session at the end of the session.
Okay. We'll keep it to that format then. Fine.
Thank you.
So go ahead, Madhuri.
Let me just share the teacher screen. I'll stop sharing this screen. Yeah.
So Madhuri is now going to share the teacher screen, which will show you what. So this was teacher will be able to see a group of students basically, right? So instead of one student, let's say the teacher will be seeing a group of students and how they are performing as a group. And overall, we will start with the competency report. So you can switch to the competency report, Madhuri. Yeah, go ahead.
Yeah. Here you can see all competency report. All competency is nothing but all chapter report. In the corporate word, we say competencies. In our university, we say chapters. Basically,
Also, another word we use in the outcome-based education is course outcome. So this competency could also be compared to the course outcome. Normally in one course, we will have 5-6 course outcomes, and each course outcome will have learning objectives. And that is, soon Pradesh is going to show you that. But here we are calling it competency instead of course outcome. Go ahead.
yeah, here we have like 4 chapter, and you can see we have 4 legend, like competent above, competent at, not at competent, not at competent minus. So like if you click on this, and you can see who all are the student who are competent above and who all are like competent at, and you can also see who are not really following. Like you see here Shivani, she's maybe very weak. So this is the view of a teacher gets it, so that it will help us to improve his instructional design or way of teaching.
Shivani, Madhuri,
Sorry.
can I see the details of Shivani?
Sure. Yeah.
So now I've gone into Shivani and I'm seeing how she's doing in all her other things. So then I see that, oh, she's purple in the first one, so she's doing well. She's okay in the second one, only in this one she is weak. So basically, what does these analytics tell you is that if many students are doing poorly in a particular topic or learning objective, as we call it here, then I as a teacher have to be worried. Why are so many students not doing well in a particular topic or learning object? Go ahead.
And we have such even chapter level reports. Even each chapter, you can see how each one is doing and how many are competent above or how many are not doing well. So you can click on each one and you can get the student details also. And also we have something interesting, pre-test and post-test. Like before taking this class, what was their understanding, and after taking class, like the post-test is like final test. What is their attainment in the post-test, and we can also do the comparison, what was their knowledge before and after taking the course, how it is. So this give you beautiful analytics of how students are learning and what is their understanding now. And we also can, we are giving the final report for the teacher, so they can see how many learning objective was there in the course, how many students are learn many things, and how many are not able to learn. So you can completely get the report of it, and you can check individual student the details also.
So there are two sets of orthogonal reports, as Madhuri is showing, from the student point of view and from a topic point of view also. And you can, from the course outcome or competency point of view, as she showed you, you can drill down to each topic. And from the student point of view, also we can drill down, to their where they are doing well and where they are not doing well. So this completes. Is there anything else, Madhuri, from you?
No, that's it, sir.
Okay, very good. So based on this personalized learning, Madhuri, can you just show your screen of one of the CEO reports here? Course outcomes. You can show the agenda also. I think we forgot to show that actually. So this is the agenda of the whole course. As you can see, it is divided as chapter, competency, and learning objectives. And in our OBE world, this same thing could be chapter and course outcome and learning objective. Same thing, basically. But basically, you can see that there is a hierarchy, and each learning objective is like a topic or a concept. And we also have the notion of key concepts, so that you can decide which are the key concepts the students must learn in this system. Okay, you can close this. Can you open one of the course outcome reports? I mean the competency reports. Yeah, just click there. Go into the next level. Click on one of the components. No, okay, great. So, sorry, close this. Can you select one of the competencies there for me?
Sure, yeah.
Okay, very good. So here, what we are seeing is, at the bottom, you are seeing the LO or the learning objective, LO1 and LO2, A2, right? And you're seeing the number of students in 4 different colors, depending on how well they are doing. So what does this tell me? Over time, if I see certain students, and remember, this is done right now at the difficulty level. Same way, I can use Bloom's taxonomy also. So the BLT levels, which are 1 to 6, could also have been used to get a similar graph. Then what I can do is, suppose in for certain learning objective or certain exams, some students do not do well at certain difficulty levels or at certain Bloom's taxonomy levels. Then what we have found in general is that it is very highly likely that they will again not do well later in similarly difficult type of questions in the same course. So what does that tell you? That tells you that these students are at risk also. Okay. And that therefore, you can train them, you can recommend to them, you can even tell their parents if necessary, that these students are at risk in these topics or in this course from the very front. Later, the same topic may come in the final exam also. So from the beginning, the student, we have predicted something and we have recommended something. And who the recommendation goes to can be defined also. Another point I would like to say from the AI point of view is that all the questions that are there, they can be calibrated. In the sense, After a while, each question will be answered by hundreds and thousands of questions by students over time. If everybody is answering an easy question wrong, if everybody is answering an easy question wrong, then there is probably something wrong with the question itself. So by using machine learning and AI, I can recalibrate the questions automatically. For example, what is thought to be an easy question is not really easy because most people are not able to get it right. Similarly, if a difficult question, everybody is getting it correct, it's probably not a difficult question. I'm just giving you two examples, but what we do is we calibrate each question, we give it a numeric value as a difficulty level, and then we use machine learning and AI to recalibrate them. So this basically ends the first part of the presentation. Now we will go to Pradesh, who will, show us. So Pradesh, Madhuri, you can stop sharing, and Pradesh, you can start sharing, and Pradesh will talk to us about outcome-based education. And, it is also part of the same software, which is Ample, which is what we are using throughout this platform. And Pradesh will be showing us that similar model, we have program objectives. Let's say a BTech program has program objectives. And let's say there is a course like, computer science or data structures. Pradesh, are you sharing your screen?
I didn't. Yeah. Yeah. Hope you can see my screen. No, sir. Can you see my screen?
Yeah. So Pradesh will then, show us how the programs and courses are done in a program. You don't have to go too much into OBE, just keep it brief, Pradesh. And
Yes.
and then at the end I will talk about the AI aspects of this. Go ahead.
Okay. Yeah. So yeah, I think most of you are already aware of this OBE, outcome-based education, because this is a mandatory thing for the NBA accreditation, National Board of Accreditation. But I'm not going much into this, but I'm just giving a overall idea what are the key terms in this OBE, and so based on that I can explain how we have included these things in our system. So I'll just go through the basic ideas of for this OBE, outcome-based education. Actually everything is evaluated, even a program, course, all the evaluation we are doing based on outcome. What is the outcome of that course and what is the outcome of that program, and whether the students are attained that or not. Basically these are the key terms: program outcomes, course outcomes, and the attainment, how this is attained or not. Basically, and how the system is designed in this system here for OBE is there will be a program. For example, computer science will be a program, or triple E will be a program, and under that program there will be many courses, and each course will have its own course outcomes, and the program will have its own well-defined program outcomes. And this course outcomes and this program outcomes will be connected. That connection we are calling it's mapping, affinity mapping. This affinity mapping will be 3 levels, like it's a strong mapping or a medium mapping or a low mapping, something like that. So these programs and courses will be mapped based on this affinity. And under this course outcome, yeah, some more things, how the attainment is calculated and all I will show you in a course structure. How? So these are the key terms I am just explaining to you. The program will be there. Under that there will be courses. Courses will have course outcomes, and program will have program outcomes, and they will have a mapping called affinity mappings. So this is a brief idea about a program, triple E program, and it will have many courses. And I will show you one more little bit detailed one. Yeah, this is also a program, triple E program, and it's having many program outcomes: PO1, PO2, PO3, and PO12. For example, yeah, by default, there will be 12 program outcomes. And under that, there will be, under this program, there will be many courses. One course is engineering mathematics, and another course is control systems. And each course will have its own course outcomes. And this course outcome will be connected to the program outcomes using different affinity. Affinity 3 is the strong affinity is there, strong connectivity is there. Affinity 2 is less connectivity. Affinity 1 is a low connectivity is there. So it can be connected based on this affinity. So overall structure I am just telling you. And now we can go to our system and I will tell you how it is implemented into this AMBLE. The same architecture we have incorporate somehow into our system. Like in our system also we have this concept called programs. We have so many programs in one center. For example, here we are seeing in ASC Amradapuri center, we have so many programs are there. Master of Computer Application, MTech VLSI Design, and MTech Power and Energy. Like this, there will be so many programs, and each program there will be multiple courses also. So that's what the overall system architecture, I would say. And here the workflow here is, in case of here we have programs and this program outcomes and program creation, those all are the HOD level process. And the faculty, the teachers will do something like a course outcome. They will work only inside a course. So an HOD or an higher management, they will design the programs and program outcomes, and they will decide these are the courses under this program. And each course will be assigned to one teacher, and teacher will do the rest with the course, and they will create the course outcomes, and they will do the COPO mapping, that affinity mapping they will do, and they will create the learning objective. They will conduct the assessments, questions, everything they will do. Automatically, all this will be linked to that program outcome. So that's what I'm just going to show you. So before that, I just want to show you one more thing here. I will just, so this is one of the small lecture plan in our university, what the teachers are using. For example, each lecture will be a, for example, the first row is a 1 to 2 hour lecture, and lecture is conducting this is the topic, the vectors and field introduction. And this topic is we are calling is yellow, that is a learning objective, and this yellow is connected to the CO1, and that CO1 is having a mapping with PO1 and PO2. So this is a like this, all the teachers is having their lecture plan. So they have to design the course into AMBLE based on their lecture plan. Actually, they should create their courses into our system in this particular flow. So they have to create a learning objective for 2 hours, and that learning objective will have a connection with the CO, and CO will be having an affinity mapping with the POs. Like that, they have to set the course structure. So automatically a course will have, this is a teacher wise, what the teachers are doing. So course will have many COs, CO1, CO2, CO3, and each CO will have 1 or 2 learning objectives. For example, here the learning objective 1 will have multiple CO connectivity also, and each question is assigned to an LO, learning objective. Learning objective is a topic. So whenever the teacher is designing a system like this, system means a course structure like this, automatically when they are creating a question, automatically that question is connecting to a learning objective, and that learning objective is connecting to the COs, course outcomes, and these course outcomes are automatically connecting to the POs, program outcomes, using their affinity. So, and the teachers will conduct some assessments, exams, and when the students are attempting that assessment, basically when they are answering for a particular question and when they are getting a 2 mark or 10 mark for that question, automatically that is adding up into this yellow level and the CO level and in the PO level also. Ultimately, it's coming to the program outcome level. So that's how the system is designed. Now I think I can show you the live system. Hope you can see my screen now, the AMBLE screen. Are you able to see it? Namaskar, Kamal sir, Jehari. Are you seeing the AMBLE screen?
No, we still see the presentation.
Sorry?
We still see the presentation only, yeah.
Oh, sorry.
Yeah, so yeah, Pradesh, what you can do is,
Yes, I'm changing that.
So Pradesh has basically shown the model overall of how to do the modeling, and now he's moving to the in Ample. He will show you the how the courses and the course attainment. So briefly, Pradesh, you can show them course attainment and program attainment quickly. Huh?
Yes. So yeah, this is how the teachers are. When the teacher logged into the system, they will see many courses, and they can click on one course and go to inside that course. Right now, I am inside one course called microcontroller application. And when I click on this course outcome, here the teacher can define these are the course outcomes. Here the teachers has designed around 5 course outcomes into the system. These are the course outcomes. And once it is defined, they can do the affinity mapping, how the COs are connected to the POs, program outcomes. So that's what they have done here. This CO1 is having a connectivity with this PO1 engineering knowledge with an affinity 3. Like that, they will design the system. They will do the mappings, COs and PO mappings. So once they do all these basic settings, after that, they can simply go to any course structure, any level, course level, and they can conduct some assessments there. Automatically, that assessment marks will be added to this COs, and based on this affinity mappings, it will be calculated in the PO level also. So this is how the course structure is created. Now I can simply show you some attainment reports. So this is one level of sample report. What we are doing is after conducting so many assessments, the teachers can go to the outcome reports and they can choose how the PO direct attainment report is working. What we are seeing here is for this course CO1, for this is a class-wise teacher report. What the teacher is saying is for this particular CO1, the class attainment is 3. For this CO2, the class attainment is 2, and CO3, the class attainment is 3. Affinities with the POs. And based on this attainment and affinity mapping, we are actually calculating the program outcome attainment. This is for a particular course. This is for a single course, microcontroller and application. For this particular course, this is the program attainment. This is for one particular semester and third semester course for AAA department. For AAA department, for third semester course called microcontroller application, this is the program attainment. Like this, each teachers will calculate their program attainment for each course in each semester. Automatically, when the teachers are completed with all this formality, process, then we can generate the higher level reports, the program level reports. That means that's what I'm going to show you next. We have many program level report. So that's what, when you come here and when you come to this BTech AAA, here I am choosing a particular batch 2017 to 21 batch for third semester. What is the attainment? For third semester course, in third semester, they have these many courses. For each course, this is the attainment. For each course, the attainment will be different, the PO attainment. Based on this PO attainment, they have a program attainment. Actually, this is the program attainment for AAA department third semester. Like this, we can calculate the attainment for the entire program. For each semester, we can calculate the attainment, and which finally we will calculate the program attainment. So like this, we have many reports. I think this is a semester-wise report, I think. Yeah, it's a semester-wise report. For third semester, batch A, what is the attainment for semester? Triple department is having batch A and batch B. 2 batches are there. So what is the batch-wise attainment? That's what we are seeing here. For third semester, for S3A batch, this is as attainment. S3B batch, this is attainment. So we can do a comparison also, how which batch is performing well and where it is going down in which POs. So we have these kind of reports, and I think the next one is the CO attainment report. I think it's an assessment-wise report. Yeah, we can calculate the attainment for each assessment. If you want to calculate, if you want to see the attainment of each exam, periodical one, what is the attainment for this, but who taught this course? And here we are showing the teacher and course, everything we are showing, average Bloom's taxonomy level. And these 42 students, their attainment is like this. For each
Hey,
assessment.
Pradesh, 1 second. I'm not seeing what you're saying.
I think the screen is not.
You have to switch. You have to stop sharing and share again. I think. Did you switch the screen?
Which actually right now I am in a particular window.
I'm still seeing your CO to PO mapping screen.
CO to PO mapping.
Okay,
Or
Jerry, what are you seeing?
Yeah, I'm also seeing the same. Yeah, it's not matching.
Yeah.
Yeah, now it is.
I think, yeah, this is I think for each tab I need to share separately because I
Okay,
open different
just,
tabs. Yeah.
We are running out of time also, so just try to summarize soon, huh, Pradesh?
Yeah.
Please.
Yes.
Thank you.
I think, yeah. I think this is an assessment-wise report. Like this, I think if I want to share more reports, I have to stop and share, I think. Yeah, let me just do 2 more reports after that. Yeah, these are some kind of affinity mapping reports. Hope you can see some color. Jerry, you are able to see, no?
Yes.
Yeah, for this particular third semester, what are the courses and how the POs are connected to this kind of affinity mapping report. Those who are familiar with the OBE reports, I think they can easily understand this. I mean, OBE requires so many different type of reports. All these different type of reports, affinity mapping report or outcome report, program attainment report, all these we are providing in this sample actually. Yeah, this is the overall idea. Kamal sir, you can take it.
Yeah. So thank you. So the intent of going from a whole program. So basically, Madhuri earlier showed you evaluation and assessment at the student level, and the teacher can use that. Now, what Pradesh has shown us is a model at the program level, right? So that we can have an entire program and all the assessments and evaluations of all the courses can come together and become part of the program. So someone can monitor the entire program. And from an AI point of view, there are a few things we are doing, but there are numerous opportunities to again see the patterns of what has been going on. So in a way, this tells us our strengths and weaknesses as an institution or as an entire program, like a BTech program in computer science or an MBA program in marketing. For the entire program, we get an idea what are our strengths and weaknesses. And then that can be used to do modeling, machine learning, AI, and then prediction or recommendation as needed. So we'll move on to the last part of the presentation from Jai Hari. How are we doing on time, Dr. Who's the in charge for the time? So just so we know, I know we are running late already.
So you can continue with your presentation.
Okay, thank you. So Jai Hari, go ahead. And so Jai Hari will be talking about why formative assessments in the classroom are so critical. We as students, we sit in a classroom for 5, 6, 7 hours every day, and teacher after teacher comes and goes. So if we imagine the whole scenario from a student point of view, it's kind of boring and frustrating for a student if the teacher is only lecturing. So what we are saying is, along with the lecturing, along with the teaching, we need to at least have maybe a quiz in between, some activity in between, so that we move towards active learning in the classroom and have formative assessments in the classroom. So over to you, Jayhari.
Thank you, Kamalji. Like Kamalji just summarized, the main problems we are facing is low attention span for the students, then their poor study habits, then lack of critical thinking, and for the teachers, the overall shortage is one of the problem. Then quality variations. So in order to overcome these things, so and to engage the class, like Kamalji was saying, the typical attention span is 10 to 15 minutes. And in schools and colleges, it is 15 minutes period for each subject. And now being COVID time, the classes are happening online, but still now I think the classes are more than at least an hour to 1.5 hours. So in order to avoid the lack of attention, we recommend a few methods in this session. So even if we are considering a digital classroom where the session is happening like this, the teacher is presenting with the help of a projector to the students. They can show multimedia content, in-class assessments can be conducted, and we can have active learning among learners. We can enhance it. Okay, so this can be achieved in three methods. That's what we are recommending. So one is the students can have mobiles and tablets. Okay, so this is the best way, but it may not be possible for schools and rural areas. So in that case, we can have clickers. Okay, so that is one thing. Then like clickers, we have Amrita cards also, which is a cheaper solution for implementation. Okay, so this is the first one, the mobile assessment method. So what is happening is like if the session is happening live or in class, the assessment can happen on the mobiles. Okay, even if the students are in classroom, the assessment, the in-class assessment, okay, the in-class assessment or quiz or poll, while after every 15 minutes or 20 minutes, there can be a poll or quiz, a short quiz, which the students can attend, and the teacher can see how well they are performing, whether they are following. Okay, so this is possible if all the students has mobile devices, and the college management allows the students to use it while they are in the classroom, and if they have, the college has infrastructure to provide Wi-Fi connectivity to the students. If all these are possible, then this will be a good solution. Then second is the clickers. So clickers means, there are small clicker devices, which is very common for conferences and all. So when we need to get a poll from the people who are attending, they will be given the clickers, and it will have a certain buttons, and when they click on the response. So if there is a question, a multiple choice question, there can be 4 options, and there will be 4 buttons in the clicker. So the participants can click on either of the buttons, and the teacher will get the response on the screen. Okay, so that is what the clicker is. It is very quick. We get the response very quickly. So that is, and it is simple to assess the entire class. Even if there are 100 students or 1,000 students, this can be possible. But it has very less chances of making errors, and it also helps to find out who has answered first. In case of a rapid fire quiz or something like that. So these are the advantages of clickers. Okay, so this is how it will look like. So if the students are using it, the teacher will present the question on a projector or a TV like this, the one you see at the left bottom. Then the students will be given the clicker devices, and they click on the device. Here there are 4 options, so they have 4 buttons here, and when they click on a particular button, we will get to know, the clicker device will get to know which option they have responded. So for this question, this was a question, let's say there were 4 options, and it will show how many people have opted each of the options. Okay, and we will also get the people's name and their score and time they took and all these things. Okay. Then the other method we propose, we recommend is Amrita card. So it is like this, which is an innovative and affordable method of taking multiple choice questions. Okay. It also captures the results directly to Ample. Like we were seeing the demo from Madhuri and Pradesh, who were showing some of the features of Ample. So these results can also go to Ample. So when we create an assessment in Ample, that can be conducted either via computer by the students independently, or it can be also conducted in a class like this. If the class is happening in a normal classroom, or if there is no device for everyone, so still we can have the assessment. We can let the students take the assessment using Amrita card, and we will get all the marks and all these things entered in Ample, which will also give the reports needed for OBE or NBA. Okay. So this is one of the screenshots when this program was conducted in one of the Chhattisgarh schools. So yeah, this was one of the screenshot, I mean, photo taken while it was used at our Amrita University. And this is another photo. So what it is it is a simplified paper clicker. Okay, so it is more or less similar to the clicker workflow. It is a paper based. I mean, we don't need a hardware. That is the main difference. Then assessment, the mobile app for teachers. So we have a teacher app, teacher mobile app, which the teacher has to install on the mobile phone. Okay, students doesn't need to have mobile phones. Only the teacher needs to have it. Okay, we don't need any special hardware. All the clicker functionalities are available at a less cost. Okay, I mean, we just need the paper, and the teacher's mobile, only one mobile is needed with a connectivity, I mean, with connectivity to internet or Ample server. Okay, then it is quick, fun, and I mean, it's for the students, I mean, kids at school and all, it will be very, I mean, they will be enthusiastic to use it. I mean, it will be fun for them. Okay, so this is how it looks like. So it has a pattern here. Okay, and it has the roll number at the top. So this is for the student of roll number 9. Okay, and it has 4 options here. So A, B, C, and D. So what happens is the student has to rotate this card so that he gets the right choice at the top. So if he keeps it like this, then he is opting option A. Okay, so if he wants to show the answer as B, then he has to rotate it clockwise 90 degree. Then he will get the answer B. Okay, so this is how the students should show. So when the teacher shows the question, so first the teacher has to show the question, each question by question in the projector. Okay, then students are asked to be, I mean, they have to show this, show their Amrita cards. Okay, and they have to show the, I mean, they have to keep the correct answer, which, I mean, the answer which they want to mark at the top. So if they want to mark A for them, then they have to show it like this. Okay, otherwise they have to rotate it so that their choice of preference of the option should be at the top. Okay, then when the teacher scans, he will see it like this. Okay, so he can see how many people have shown A. Okay, 6 of them have shown A, 1 of them have shown B, then 1 C, and no D. That is how it is. And when it is, I mean, if the correct answer is given, then I mean, this is a preference. So if the preference is set to show the correct answer, then it will show correct answer with a green color. Okay, so here B is the correct answer. And at the left side, we will see the roll numbers. So in this screenshot, I mean, I show only 10 people. So we will get to know if all of them are showing the answers or how many are captured. Okay, so that is how we have it at the left side. I mean, it's a bigger screen. So the scanned roll numbers will get to change to green color. Okay, and we will also see the options they have shown. Okay, so that is how it works. So when the assessment is happening, the students has to show this for each question, then the teacher has to scan it. And the scanning is not like one by one. I mean, it can scan all the cards visible to the camera at once. Okay, so teacher can just move the camera a little slowly. I mean, like in 1 or 2, I mean, maybe maximum 5 seconds, we can cover the entire class of 50 to 60 people. And there is no limit for these cards. So we can create as many cards as we want. And here are some AI applications which can be built on. So one is like we need to know which all, I mean, from from the students' previous performance, we get to know how the students are performing for each learning objective or topic. Okay, so based on that, we know if students are understanding. I mean, we have the question mapping, whether the students are performing good for the questions of understanding type, remembering type, and all these things. So based on that, we can say, okay, for these topics or these learning objectives, the students are not following. It could be because of lack of attention, and which may get reduced after a while. So that could be the thing. So in that case, for this assessment or for this topic, we recommend to have an in-class assessment. So that is one application. Then second is, this works, this Amrita card scanning and all these things works pretty well when we have good lighting. But in case if there is no proper lighting in some area of the card, so let's say in a rural place, if the lighting is not proper and only the half the card, or if half the card is not visible fully, or if it is not visible clearly, then we can also use AI and image recognition. We can have multiple images captured, and these images can be used to improve the pattern matching algorithm which we have. So these are the main AI, and I think I have covered how we can use Amrita card for in-class assessments. And as soon as we conduct the assessment, the teacher, when he finishes the assessment, the results will be automatically synced with Ample reports. So the reports can be generated from Ample. Kamalji, over to you.
Thank you, Jayari. So as we have been showing you, I'll just go back to the one slide that I showed you earlier. So what we have done here, we have numerous other applications that we have built in our e-learning research lab, around 8 to 10 of them. I'll just briefly mention a few of them. One is, for creating automatically grading assessments. As we go to MOOC platforms, we need to automatically grade assessments. So some tools are coming along in this area, which have an AI flavor to them. And almost, I think, any activity which we as teachers have to do repeatedly, can be automated. But I think the most fundamental thing is, are the students learning, and do they have interest in the learning, and how to give them freedom and yet ensure that they learn. Those are the most challenging questions of our education system. And if we use AI in those areas, then that would be the maximum benefit for the system and help us. So based on that, we had picked these three presentations today. So we would now like to invite any questions, comments from all of you.
Participants, we are open for the QA session. If you have any questions, you can raise the hand or you can post your questions on the chat box. There is one question in the chat box from Mohan. What is the app to be used to scan the card?
Sorry, can you repeat that, ma'am?
What is the app to be used to scan the card?
Jerry, what is the app used to scan the card?
So it is called Ample Teacher app, but we haven't put it on Play Store yet. Currently, it is being used by a closed group people who are interested, and I mean who are part of our community to enhance this. Soon we will be putting it on Play Store. So I mean, it's part of Ample. So I mean, if we put it on Play Store, also only the people who are using Ample may be able to use it now currently, as the reports and all are getting generated on Ample.
Any more questions, participants?
Hello.
Yes, sir. Vaidya, sir.
Yes. Can I ask the question?
Yes, sir.
Is it question answer session?
Yes, sir. Yes, sir.
Yes, sir. Thank you, Dr. Kamal, sir. It is very nice that you have presented so many things, and hope the faculty will also got motivated, and maybe they will be using the things. So my question is that how we can do a kind of a collaboration from both point of view. One is from research point of view, as well as another is from implementation point of view. So if you just elaborate the thing on this, so that will help us.
Sure. So as you know, we have all we are keeping Ample as the central platform here, and so that is what we along with we are collaborating with industry also now. So we want a complete collaboration with colleges, universities, and industry, so that we can build a very low cost, affordable platform that all of us can use, and we can build it together. So that is the intent of that. So that we can enter into some kind of a MOU or something like that, and then we can jointly allow the usage as well as the core development of some modules. I think those would be the next steps.
Thank you very much.
Sir, there is one more question. The question is, the question generated in the app is fed by the faculty or automatically generated by AI system?
The question, I guess is about the personalized learning, I suppose. So the questions in the personalized learning, which we showed first, they are generated by the faculty. And they are classified as easy, medium, or difficult. Is that right, Madhuri? So that's how it would be. Yeah. So yeah, they are created by the faculty, and they also have to be classified, as easy, medium, or hard. And the faculty has to create a group of questions. So let's say I have a particular concept, let's say Newton's law. So if I have Newton's third law, every action has equal and opposite reaction, then, I put Newton's third law there. Then I have few questions on remembering Newton's third law, let's say. And then I have a few questions on, applying it. And so, some reaction forces or questions like that. So each of these set of questions, then, once I have a few questions, I may just make some minor modifications of the question. Instead of a certain number, I may change the number and increase the number of questions. So then what I would do is, for a particular concept like Newton's third law, I would come up with several learning objectives, and each learning objective, let's say, would be having multiple questions at multiple difficulty levels. And then once I have set that up as the master teacher or the master trainer, then all students can use that system to test themselves. So that is how the whole complete setup is done for personalized learning. And also, as the teacher, instructor, you can define how many questions each student gets asked.
Okay, sir. Thank you. On behalf of MESS IMCC and all participants, we sincerely thank Kamal Bijalani sir for accepting our invitation and delivering the talk. It was an outstanding coverage of AI, sir. Thanks for sharing your valuable research work in this FDP. It will be truly beneficial to all. Thanks once again. We look forward to connect with you again in our future events. We also thank Madhuri ma'am, Pradesh sir, and Jai Hari sir for experimental tour of different AI applications through the presentation. I thank all participants for their enthusiastic presentation and participation. Now we will conclude